Let's improve your building IQ with more garage and loft framing videos. In this video, we are going to put a gambrel style roof on top of our garage with a loft. Now, even though I'm going to provide you with the framing information, I'm also going to provide you with some information at the end of the video that might provide you with a better way of building something like this. Now keep in mind that I am not a structural engineer, even though I do have a pretty good understanding about what might be required because of the time I have spent building and designing my own projects. So with that said, let's go ahead and remove the roof. And since I have already provided viewers with the information on how to get to this point here in a previous video in this series, I would suggest going and checking that out if you want more information about how we got to this point here. And another thing I will not be providing you with is step-by-step guidance on how to assemble a project like this. And as you guessed, the reason for that is because I already have a couple of videos on that. So feel free to go to the website and check out some of our roof framing videos, which should provide you with a way to figure out the height of the walls and the location, along with the roof rafters. And here we are going to be lapping the roof rafters here to create a stronger connection. And the rafters at the bottom will be shaped so that they will look something like this. And of course you can toe nail the rafters into the framing plates here. And then toe nail the rafters into the framing plates up here, along with using some 16D nails to fasten these two rafters together here. So maybe somewhere around 4 or 6 nails to fasten those rafters together. And then you can end nail the rafters here or toe nail them to the roof ridge. And on this side of the building, I went ahead and lapped the rafters and installed another board here to create a flat surface for the wall framing and provide you with another method of how this can be done. On the other side, I'm going to do something else. And I went ahead and extended the roof ridge 3/4 of an inch so that the breaks between the two pieces of fascia board will be nailing into the ridge. However, you might need to reshape the end of the fascia board here, depending upon what size fascia board you're going to be using. Next up, let's go ahead and install our blocks. And that will be a row of blocks on top of the wall framing here, along with the framing plates. And I would suggest shaping the top of them to match the roof rafters. And even though I didn't put it in the video, you might want to run another block over here and then fasten it to this block here so that you can get roof sheathing perimeter nailing at the break between the sheathing here and the sheathing here. And you might need a different saw to shape it here or to create a nice connection between the two different roof planes here. And of course, the bottom blocks will need to be shaped also. And our roof rafters are spaced 16 inches on center. And now let's go ahead and take a look at how we finished off the rafters on this side, along with our exterior wall with our doorway in it. And of course, we are going to be framing the roof a little different on this side, where the two rafters here will not be lapping like they are over here, to provide you with another way to finish this side of the building off. Next up, we are going to be installing a 1x4 around the perimeter edge of the gambrel style roof to provide us with an overhang that we will be able to slide our siding or stucco lath paper along with the netting and the finished stucco to provide us with a nice way to create a waterproof, or at the very least a water resistant transfer between the roofing and the wall finish. And on your project, you might need to install a 2x4 here or even something larger, depending upon the type of finished material you're going to be using. And of course, the 1x4 will go all the way around the perimeter, including the top of the ridge here that I mentioned earlier. And you can see here where you could have ran the 1x4 up and left the ridge even with the wall framing. However, I like to be able to nail the fascia board into the roof ridge here. However, if you do it the other way, the building probably isn't going to fall down, so don't worry about that. that. And as always, I will leave that decision up to you. Next up, let's go ahead and install our fascia board. And our fascia board is going to be 2x6. And the top of the fascia board will plane into or be even with the top of the roof rafters, so that our roof sheathing will be nice and flat. Next up, let's go ahead and take a tour of the fascia board here. Get an idea of what it looks like closer up, and how the top of this board here is going to be angled to match the plane of the roof here, and even a 45-degree angle, something you can cut with a circular saw, might work just fine here. And of course you could always change the corner detail. And here you can see where the fascia board is sticking past a little bit, so we can slide our siding underneath into this slotted area along with our building paper. Next up, let's go ahead and install our roof sheathing. Now this might not work for you. You might need to bring the sheathing back a little bit depending upon how you're going to finish this area here. And you might be able to finish it with some roofing edge metal. And that edge metal would go all the way around the perimeter here. And this should give you a pretty good idea how the roof sheathing will work out. And we are using 4x8 sheets of either plywood or OSB. Now I wanted to point out that you might or might not be able to fudge the sheathing a little bit like I did here. I moved it 1/4 of an inch here, and then I pulled it back at the top a little bit so that I could get my perimeter nailing. So it would have been better if I had about 8 foot 3/4 of an inch. But like most of you, you're not going to be interested in purchasing more lumber when you might be able to reposition the sheathing just a little bit, or maybe even run a row of blocks down the center here so that the perimeter nailing of the roof sheathing will work. And that about wraps this roof up here. However, I'm not 100% sure that our previous example is going to provide us with a structurally sound building, where in this example it might work a little bit better because we're going to install a ridge beam. And yes, we're going to need to redistribute the weight for that ridge beam and even install a post somewhere in the center. So if you don't like the post in the center, then I would suggest contacting an engineer to see if they can provide you with a different design. Now here's the reason why I'm not 100% happy with this roof, and that's the fact that we have about a 53-degree angle here, whereas if you change this to a 45-degree angle or less, then you would be able to create a brace, something that would prevent this wall from moving in this direction, because the weight from the roof above might want to push this out, and the angle here might not be enough to prevent that from happening. However, something like this might, and I've seen this used before. Someone goes in and installs a brace like this. However, you might need a brace like this on every rafter or 4 foot on center, but I won't be able to provide you with that information. However, I can provide you with some information on how to attach the brace to the wall framing. And that will probably include having 2 16D nails toe-nailed through the brace into the wall framing plate, and a couple of end nails going into the wall framing studs. And on almost every project like this, someone usually has access to this area for storage or even maintenance. So I went ahead and framed out an access opening that might look something like this. So again, some type of a bracing system might solve your problem. And if you don't like the bracing idea, then I think the ridge beam will solve your problem. However, let's not forget that we are going to need to make some modifications to the floor framing, and that will include some type of a doubler or a beam that will transfer the weight of the post supporting the ridge through a post on each side and then down to the building foundation. And here's something that a lot of framing carpenters forget, and I've even done it myself, and that's to include some type of support blocks to transfer the weight a little bit better through the floor framing and then through the support posts in the lower wall. So another thing to consider when you are working on a project like this. And of course you will need to do that on the other side. And don't forget that if you don't like the post in this spot here, that you can relocate it. And basically you can move the post away from the center if you need to. And what this is going to do is probably going to change the size of the longer beam. So for example, if I move the post over here for some reason, and I had a 4x12 beam here, then I might need to put a 4x16 in this section here. Or if I wanted to get rid of the post, then I might need some type of a paralam or a glue lam in here to span the distance. So don't get sold on the idea that you do need a post in there. However, if we do move the post, let's not forget that we're going to need to move the support beam. And I'm sure that's something you're not going to forget about during the design or construction part of the project. And if you do go with a full-length beam and no post, then you might need a larger header. And you can see here how the weight from both sides of the header transfers down through the posts and to the building foundation. And just kind of get a close-up view of how I made the header work here. Header, we have a post supporting the beam and how it ties into the rafters here. And of course we could always extend the king stud up a little bit to get some nailing into the header. And we could always use some type of a strap to provide a better connection between the roof rafter, the beam, and the other roof rafter. And you could always angle a strap here or put a couple of straps in here to provide a better connection between the post and the header and the ridge beam, or even find other building hardware that will provide a better connection. And the last thing I want to mention is that you might need to install some type of a strap over the rafters and a roof sheathing, or you'll need to install some collar ties to prevent any uplift in the roof framing system. And if I have done my job right, then you have a little more information about building a gambrel roof, some type of a loft or storage area, or even additional living area over a 20-foot by 24-foot garage. In this video, I will be providing you with a few structural designs that might make the floor framing stronger. And this video is part 7 in our series for building a 20 by 24 foot garage with a loft above it. So let's go ahead and get started with our original design, where we have 3/4 inch floor sheathing. And you can use whatever you desire, plywood or oriented strand board. And you can always go back and watch the first video for more information about this floor. But it is basically going to be framed out of 2x12 with lag screws attaching it to the wall framing. And in this example here, we have 2x12 for the floor joist and 2x4s for our wall framing. And the 2x12s are spaced 16 inches on center. And as one of the viewers pointed out, that might not provide you with the best floor. And as I suggested in one of our other videos, 12-inch on center floor joist spacing might work better, along with the first variation that we have here, and that would be a larger ledger, maybe a 2x14 so that you could install a few more lag screws. Or in our next option, you could go back to the 2x12 ledger and install 2x4s or larger framing studs underneath the ledger and attach them to the wall framing studs. And for those of you who are new viewers to my channel, this is the first time you're watching one of my videos, I also need to point out that I am not a structural engineer and that you might need to consult one before building one of these projects. So keep that in mind when you are designing your project. Another idea that you might want to use will be to install a larger wall framing stud like a 4x4 where the rim joist breaks so that you can get a better connection. And let's not forget that you can use a combination of everything in this series to build the strongest floor possible. And to provide support for our wall framing studs, I simply installed a 2x6 sill plate instead of a 2x4. And something like this might require you to make the concrete stem wall a little wider. But again, that will depend upon the engineering involved. My next suggestion would be to install 4x4 or even 3x4 wall framing studs. And these can be installed 16 inches on center, 32 inches on center, or like we have in this example, 48 inches on center. And the 4x4s will also provide us with additional strength for the outside wall. For those of you who have already addressed your concern about the weight of the roof putting pressure on the wall and trying to spread it apart. And this could be a bigger concern as you raise the height of this wall. For example, a 2-foot tall wall will probably provide you with a little more resistance to spreading or bending the wall framing studs than a 4-foot tall wall would. And if you don't like the 4x4 idea, you can always put in 2x6s or 2x8s. And the wider wall framing studs might also help you with insulation or allow you to put a thicker insulation in the wall framing if you live in colder areas. The wider wall framing studs will also allow you to stagger the lag bolts. Another idea will be to install a ribbon, and this could be a 1x4 or a 1x6 that's going to be notched into the wall framing. And if you lay out the wall framing studs and the joist correctly to where they lap something like this, you'll be able to nail them to the wall framing studs and create one heck of a strong structural floor framing support to connect the joist to the studs, especially for those of you concerned with the wall spreading away from the floor framing. Next up, let's go ahead and remove the joist so you can get a better idea how the 1x can be notched into the framing studs. And if you have a concern that this is going to weaken the wall framing studs, then you can always go to larger wall framing studs like 2x6. And this is actually one of the methods carpenters used years ago when balloon framing walls instead of platform framing like we use today. And you could always do something like this where you notch for the ribbon and then have the joist connect to the wall framing stud. So that would be where it's sitting on top of the ribbon, but yet you're going to nail it into this wall framing stud. And I have only built something like this once, and it was in a commercial building. So I'm not 100% sure that even though this is going to provide you with a nice connection between the joist and the wall framing studs, I'm not 100% sure that it's going to provide you with the best option for the weight transferring from the joist down to the building foundation. However, this option will, instead of the ribbon, we can go ahead and install some wall framing studs underneath the joist. And this is actually an option that one of the viewers pointed out. And this is actually a method that I have used before on smaller platforms like stair landings. You could use 16D nails to connect the joist to the wall framing stud. And again, this method here seems to be a little bit stronger than the previous example we looked at with the ribbon cut into the wall framing stud. So again, something like this isn't going to weaken the wall framing stud by cutting a notch out of it, and will provide us with a nice transfer from the joist down through the wall framing stud to the foundation. And as always, I saved the best for last. This is probably going to create the strongest floor framing system. And if you wanted to make the wall framing stronger, then you could always go to larger framing studs. So in this situation, we have the joist sitting on top of a structural load-bearing beam, transferring the weight through the post down to our footings. And we're not going to be notching for the ribbon to weaken the wall framing studs, yet we're still going to get the nice connection here where we can attach the joist to the wall framing studs. So let's go ahead and take a look at this example here where we have the post, the connector, and the beam. All of the blocking. And if we use a center post, especially for those of you who have problems finding larger lumber or somehow getting it to the property and need to use smaller beams, then you could always break the beam here to where you could have a 12-foot beam on this side and a 12-foot beam on the other side. So keep that in mind when you're designing your project. Next up, let's go ahead and take a look at the joist to the framing stud connection and our fire blocks. And next up, let's go ahead and remove the floor joist and take a look at the space between the beam and the wall. And the space here is going to be the distance between the curb and the wall framing, or this distance here. And even though you can bring the post closer like I have done at the other side, the beam can usually cantilever this distance without a problem. And try to leave a gap between the wood framing and the concrete, maybe 1/4 of an inch. And of course you can see here where we have the break in the beam. And if this is too long of a cantilever, you can always move the post closer like we did on this side. And if you're building this new, you're not remodeling it, you could always build it to where you have the post right up against the wall framing. This way you can attach the beam to the wall framing studs with some type of building hardware. So again, you can always have something like this with a post base connector coming out of each footing and no gap between the wall framing and the beam. And you could always install framing anchors or L brackets to connect the wall framing to the beam, along with using blocks in between the joist that will be sitting on top of the beam instead of hanging like it would be if the gap is larger than 1.5 inches. And like I already said, if something like this isn't going to be strong enough, then you could always use larger floor joist and reduce the on-center spacing to provide us with even a stronger floor and a stronger wall framing system. So in this example here, we have 3x12 joist spaced 12 inches on center, along with our 2x4s that we could always change to 2x6 to create something that probably only a fire is going to take down, especially if we cover the exterior wall framing studs with shear panel. And another thing, of course, you could do would be to bolt the joist to the wall framing studs. And that is the end of my floor framing suggestions. This episode here, I'm going to modify the roof and wall framing so that we can get some headroom for the stairway. And this is also going to be my first example. I have a couple of more ideas for the roof. So let's go ahead and get started by taking this thing apart, and I'm not going to spend that much time taking it apart like I normally do in some of my other videos. Just kind of give you an idea. And again, you can pause the video and stop it if you need to take a look at something at any time during the video. So there we go. We have our wall framing. We are going to start here, where instead of having the studs extend past the floor, we're going to have the floor sit on top of this section of the building. And the wall height here will be 8'1", or a standard 92¼ inch stud. And the floor framing on the other side will be the same. We're still going to have our doubler here, except that the doubler will be sitting on top of the wall, along with another doubler over here to support the wall framing that's going to be supporting the roof framing, along with some blocks, because in this area here, we're probably not going to be able to use the tongue and groove for the floor sheathing. And if I would have left the floor sheathing alone, I would have ended up with about a 4-inch strip over here. And that's because most structural engineers require a 2-foot minimum distance for the length of a piece of floor sheathing, and that's usually going to be in any direction. And don't forget to install the double studs underneath any point where you're going to have a doubler that will require some additional structural support, and that will go for over here also. And even though I didn't put one over here, this is probably going to need one too. And of course a view of the blocks there. Let's go ahead and install our floor sheathing. And if you go back to the first video, you can see where the floor sheathing would have stopped right here. So we would have had a 4-foot sheet from here to here, leaving us with about a 3.5-inch strip going all the way across. And hopefully that makes sense. Let's go ahead and install our wall framing. And you could always have these studs go all the way up and underneath the wall, but I wanted to provide you with another example of something that you could do. And I will go into more details on this in some future videos. And in order to determine the height of the wall framing in this video, I worked my way backwards from the top of the ridge down because I wanted to have the two ridges intersect. And that'll make sense here when I get to the roof framing. And I'm also going to need a double roof rafter to support the valley rafter. And then another board here to nail to the wall framing. that will provide additional structural support for the roof sheathing. And the width of this area is usually going to be determined by your building codes. And in our example here, I made it a little bit larger than 6 feet because most building codes require a 36-inch by 36-inch minimum for a landing area, even though this direction here is about 4 foot. This direction here is about 6 foot 4 inches. Next up, let's go ahead and install our roof framing, our rafters, our fill rafters or jack rafters, and our valley. We have a valley on each side. And for those of you wondering why these rafters are over here, why it's shorter here, that's because I used the same fill rafters on each side, or the same measurements, where in reality you could have moved these over and got rid of these two. It's just that they wouldn't have lined up there, and that's just something I think I do out of habit. And don't forget our rafter ties here, and you might need to install ceiling joists if you're going to drywall. And our fascia will stop here, and you can see here where this board here is going to nail to the wall and then support the roof sheathing. Our gable end here, let's go ahead and install our gable studs and our shaped blocks. And you could probably use smaller rafters. We're using 2x10 here. And a view of how the valley is going to die into the wall here. It's going to be sitting on top of the wall. And this little slot right here is going to be for our fascia board. Our fascia board is going to sit on top of the wall framing. And this piece of fascia board is going to notch over the roof. However, if you were to extend this section of the roof framing out a little further or lower the roof, then you can actually create a straight line here. So you can see where if the roof extended over to about here, then this board here wouldn't notch over the roof framing, and sometimes that looks a little goofy. And then we are going to install one lookout. Another view of the valley here, and of course a view of the ridge, how it dies into the other ridge to where it's going to be even or flush with the other ridge. And like I said, you could get rid of this rafter by moving these two over, starting 16 inches on center from here and going this way. And then the load transfer is going to come down through the valley rafter to the double rafter. That's why we need a doubler here. And I say that's why we need a doubler there, but don't forget, this is not meant to be structural engineering information. And roofs like this might not be able to be built in areas where you have snow loads. In a view of how these rafters will need to be shaped to sit on top of the other roof, and a view from the bottom, and you can see here where this would be difficult to drywall. And if you were going to drywall the ceiling, then you might need to make the valley rafter a little smaller. So keep that in mind when you are designing your project. A bottom view of the rafter ties here, and another view of how the valley intersects into the doubler there, along with how I extended the framing plates to just provide a little support for the roof rafter here, even though most of the support for this rafter is going to be transferred to this section of the roof. And even though I didn't do it in this example, don't forget that you could always extend the wall framing all the way over to where the valley rafter will sit on top of the wall framing, and then you might not need the doubler here. However, I didn't do that in this design because I didn't want to extend the wall into the storage area even further. Next up, let's go ahead and head back to the top here so that we can see how the roof sheathing and the sleeper board or the backing board is going to work out. And even though these two rafters will be sitting on top of this backing board, it's always going to be a good idea to leave enough room so that you can slide shingles or roofing materials underneath this section. And for those of you who are going to be hiring a roofer, wouldn't be a bad idea to have them come out and take a look at this area to make sure that it is going to be built correctly. So there you can see where we have a gap here, and we will have the same thing on the other side. And I don't know if I have another video on that. If you need something on that, let me know. And it will always be a good idea to leave this piece off so that the roofer can finish this section here without this being in the way. And again, that might be something that your roofer will need to go over with you. And even though I left a larger gap here, you might not need to do that. As long as this piece here is removable, So see how the fascia board is cut a little shorter for the gap there. In a view of this from underneath. And again, like I said, I would imagine most architects aren't going to like that notch there. However, they might like the wall here that is set back instead of extending forward to support the valley rafter and making the room look smaller. So there it is from the front of the garage. And I will wrap the video up here by taking a look at the other side of the garage. And for those of you who I might have lost somewhere during the way, feel free to leave any questions in the comment area. And don't forget to hit the thumbs up button if you enjoyed watching the video, or even better, learned something from it.